In order to estimate the area of the irregular shape shown below, a horizontal line was drawn across the widest part of the shape, and 5 offsets, that is, perpendicular lines, were drawn at equal intervals along this line. Find the lengths of the horizontal line and the offsets, taking each grid unit as 5 mm, and record the lengths in the diagram. So the grid unit is this distance here, it's 5 mm. So the distance from here to here is got by counting the squares, there are 4 of them, and multiplying by 5 to get 20. This distance here is also 20. So is this. All of these distances are, these horizontal distances are 20. Now what about this vertical distance? In part 2 we'll be using the trapezoidal rule to estimate the area of this shape. We could divide this shape into 2 regions, the region above this horizontal line and the region below this horizontal line, and apply the trapezoidal rule twice and then add the 2 results together. However, that's equivalent to applying the trapezoidal rule to the entire shape, where we work in this total distance here, and that's what we have to get in question 1, the length of this offset. So how many squares make this up? Well, we have 4 above here and 3 underneath. 7 small squares, 7 5s are 35. So when I write 35 here, I mean the total offset. Here we have 5 squares above, 4 underneath. 5 and 4 is 9, 9 5s are 45, and so on. Now we're going to use the trapezoidal rule to estimate the area of this shape. So what we do is take this horizontal distance, these are the distances between the offsets, which are all the same, and divide by 2. Then we multiply this into the first offset. Now the first offset is actually 0. That's the distance of this horizontal point up to the curve. The last offset is actually 0 as well, because the curve meets the line. Now these offsets are the total lengths of the vertical lines. So it's 0 here and it's 0 here. Then we have 2 times all the other offsets. So the distance from here to here is 35. Distance from here to here is 45. Then 60. Then 40, and then another 40. Calculating all of this, we get 4,400 millimeters squared. We could have done this problem by, as I said earlier, just looking at the top part of this shape and applying the trapezoidal rule, then looking at the bottom part and applying the trapezoidal rule, and adding the 2 results together. But that would be just equivalent to adding this distance onto this distance to get 35 for this figure here, and then adding this distance onto this distance here to get a total of 45 total distance. Similarly here, this total distance is 60, and so on. So applying the trapezoidal rule twice is equivalent to just using the trapezoidal rule once and just taking the total distances here, rather than just the offsets above and the offsets below when we take the trapezoidal rule for the 2 parts separately. So it's easier, quicker just to combine them into one single formula. Just realize that these values are the total lengths of the offsets.